So in starting Unit 15, we're going to be talking about proportions. And we're going to start off with a problem with proportional reasoning in artwork. We have a scenario here where the Heart Health Association is holding a 5K fun run or walk, and an artist has donated his time to enlarge the logo for the advertising banners and the t-shirts that will be given to the runners. So when you're a professional like a graphic artist or an architect or an engineer, you have to often take things that are a certain size and either enlarge them or shrink them. When you do that, you don't want the logo to look different. You just want it to look smaller or bigger. So you don't want to stretch it vertically or horizontally without doing the same thing the other direction, because then it would be distorted. So we're going to look at the original here and try to figure out which one is the correct enlargement of the original logo. So it says that the artist wants to set up a spreadsheet to calculate the dimensions so that she can reuse it for future projects. It's funny because up here it was a he and now it's a she. But anyway, she's not sure how to write the formulas correctly and tries different options. Which one of the three options creates a proportional relationship? So if you look at this, we have across the top, this is set up kind of oddly, but across the top these are all the same, 1.67, 2.49, 1.67, 2.49. So we're trying to figure out whether this one is correct, this one is correct, and this one is correct, going from the original to the t-shirt and then to the banner. So the original logo, if we look at this first one, we can pretty much rule this one out very quickly, because the original is 1.67, and you can see for these options that they haven't changed the height at all. So what they've done is they've taken the original and they've left the height the same and just stretched it horizontally. Well, that's not going to keep the same proportions. It's going to be distorted, so this is definitely not the option that we want. Let me try that again with a thicker pen. Okay, so this one we can rule out because these are all the same. Okay, so because of these all being the same, we know that's not okay. So now we're going to check the next one. So we've gone from 1.67 to 6.68 to 25.05, and then from 2.49 to 8.72 to 32.37. Now, they have definitely in this column increased the height and the width, so at least it's a possibility that this one might be right. So how do we check that it's correct? And there's a couple different ways we can do it, and you kind of need to decide what works for you and what you like. The way that I like to do it, but I'll explain a couple different ways. The way that I like to do it is just to set up a proportion. So if we look at the original, 1.67 to 2.49, does this option get the same comparison between the two, or the same ratio between the two, as 6.68 to 8.72? Now, even writing it this way, there's a couple different ways we can look at it, but I like to write it this way first because I think it's kind of visual. So we've got 1.67 for, on both of these, we've got the height on the top and the width on the bottom. So we have a 1.67 inch height to a 2.49 height. How does that compare to a 6.68 height and a 8.72 width? So as we look at that, we can do two different things that are fairly common to check this. We can see what would 1.67 have to be multiplied by in order to get 6.68. So we're going to take 6.68 and divide it by 1.67, and that gets 4. So this has been multiplied by 4 to get 6.68. Well, if you've stretched the height 4 times, if you want the image to be proportional, to not be distorted, you would want to multiply the width by the same thing. So is this multiplied by 4? So is 2.49 times 4 equal to 8.72? And the answer is no. If you do that, you actually get 9.96. So this is not correct. This 8.72 is not wide enough to keep the original image looking the same. And there's no need to check the second one because we're supposed to pick one of these columns. So if that one doesn't work, then this one's out. So now we'll check this next one. So, and again, this one was bad. So we'll check the next one. We'll start with our 1.67 to 2.49. And I'll show on this one how to check the other way because I know I only showed one way there. Wrong number here. I want to do the one from this column. So 1.67 to 2.49, is that proportional to 8.35 to 12.45? Again, I'm putting the height of the t-shirt possibility over the width, and I'm putting the height of the original over the width. So height to width, height to width. So now I'm going to do the method that I did up here. What would I have to multiply 1.67 by to get 8.35? So 8.35 divided by 1.67, and you'd have to multiply to get from here to here. It comes out to be times 5. So if I take 1.67 times 5, I get 8.35. So now we're going to check on the bottom here and make sure that this is also times 5. So I can either take 2.49 times 5, or I can take 12.45 and divide it by 2.49 to see if I get 5. I'm going to do 2.49 times 5 because it's easier. And I do get 12.5 when I do that. So that's the correct proportion in both directions. The other thing that we can do, and I'm going to go ahead and just get rid of what I wrote here and use the same thing. Instead of checking if it's multiplied by the same thing, I could also cross multiply and see if I get the same number. So if I cross multiply this way and I cross multiply this way, I should get the same thing if they're proportional. So 8.35 times 2.49 gets me 20.7915. And if I take 1.67 times 12.45, I also get 20.7915. And so either of those checks would work. I can either see if it gets multiplied by the same thing top and bottom, or I can cross multiply and see if I get the same number. What I get for this number doesn't matter as long as I get the same thing on both of them. If I get two different numbers, then these ratios are not proportional. They did not get multiplied the same top and bottom. As you can see, when they do get multiplied the same top and bottom, we get the same number. So now this is okay. We can see that that row is okay. So let's double check this one. We're assuming that the banner is okay, but we'll just double check to make sure. So 1.67 to 2.49, that was the original. And we want to see if the banner is okay also. And it's 23.38 to 34.86. So I can cross multiply like I did here, or I can see if it got multiplied by the same thing. So 23.38 divided by 1.67 gets me 14. So this has been multiplied by 14. And 2.49 times 14 does give 34.86. So in both of these cases, if you multiply by 14, you get the same equivalent ratio. You could also, as a third option, so the first option is to see what it was multiplied by and see if it's the same thing. I can cross multiply and see if I get the same number, or I can even take the top number divided by the bottom number and see if I get the same thing. So if I want to do that, if I take 1.67 and I divide it by 2.49, I get 0.67 approximately. It's a little bit bigger than that, but not too far off. And if I divide here, 23.38 divided by 34.86, I get the same 0.67 number. So any of those three ways is perfectly fine, and whichever one makes most sense to you is perfectly fine to use. So you could see what did it get multiplied by and see if it's the same thing. You can cross multiply and see if you get the same numbers, or you could take the top divided by the bottom, top divided by bottom, and you should get the same numbers. So that should give you some options, and you do not need to do all three methods. Just pick whichever one you like the best and use that one. And I would say stick with that method, because that way you don't get confused and you don't need to do all three of them. You just need to be able to do one. So that one works also. So it says use the correct option from question 1, which was this one, and write the spreadsheet formulas that are used to calculate the width for each version. Use the column and row labels shown above for the cell references. So what they mean by that is, instead of actually putting in the 8.35, how did we get from the original to the t-shirt? So what they're saying is, if you wanted to calculate row H3, the t-shirt cell here, the t-shirt height, that would be gotten by taking H2 times, what did we decide? I believe it was times 5. So to get from here to here, you would take times 5. And then to get I3, what you would put in that cell is whatever I2 was times 5. So to get from here to here, you would multiply by 5. To get from here to here, you would multiply by 5. And then for the bottom cells here, to get H4, you would take H2, remember that was 14, times 14, and to get that was wrong, that would be I. To get I4, which would be this cell, you're going to take I2, the original width, times 14. And then this way, if they put these in here rather than just putting the numbers in, if they actually put this formula into that cell, then it would calculate the height and the width no matter what you put in for the original size. So you could change the original size of the logo, and it would calculate how big should the t-shirt logo be, how big should the banner logo be. So sometimes they'll use that in the spreadsheet so that they don't have to keep recalculating it. They can let the spreadsheet calculate it for them. So they could just go back and say, okay, well, my original for this company is, 2.2 by 3.1, and they could put those in there, and then it would automatically calculate those if they had this formula in the cell rather than actually putting the numbers in themselves. So now let's go up here to question 3. It says, you are a graphic artist hired to make a billboard for a college. The original college logo is 2 1/4 inches wide by 3 3/8 inches high. You need to enlarge it to a height of 6 feet. How wide will the enlarged version be? Well, right now we've got a mixture of units. We've got, well, we do have a mixture of units. We've got the original that's in inches and the enlargement that is in feet. As strange as it may sound, we actually don't need to change that, because remember, we're just trying to be proportional. So as long as I keep the original logo both in inches and then the enlarged billboard in feet, I don't actually have to change the units. Let me write this down. So you have your 2 1/4 inches to your 3 3/8 inches. And basically, because this is a ratio, the inches cancel and they don't really matter. We just need to make sure they're both the same unit so that when we come over here, the units won't matter either. So then the height, this was width to height is how I had written this. And then here I would want the width to height. So we don't know the width. How wide will it be? But we do know that the height is 6 feet. These units this is hard to work with because of it being fractions, so let's take care of that. 2 1/4, if I want to change that to a decimal, I need to take the 1 divided by 4 and get a decimal for that. Now, most of us know that because we see that a lot, that 1 divided by 4, or 1/4, is 0.25. So I could rewrite this as 2.25 5 inches. And then the 3/8 is more uncommon, but if I want to switch that to a decimal, 3 divided by 8 comes out to be, and if you work a lot with, if you do a lot of building, you may know some of these from that, but that comes out to be 0.375. So if you divide 3 divided by 8 for this 3/8, that would be 3 inches for the 3 inches, and then 0.375. And we want to know what would I need for a width in order to have a height then of 6 feet. So I just rewrote this proportion with decimals in it rather than the fractions. There's more than one way to do this, but I think the easiest way is the cross multiplication. So I'm going to show that. So we could cross multiply here. You get 3.375 times W. We don't know what that W is, so we just have to leave it W. And if I go this way, 2.25 times 6, I get 13.5. And if I divide to get rid of that 3.375, I'll do that in red since we're solving the equation. I'll do kind of like we've done in the past. So divide by 3.375 to cancel this. But whatever I do to the left side of the equation, I've also got to do to the right side. So I'm going to divide this by 3.375. So 13.5 divided by 3.375, and I get an answer of 4. So the width of this would need to be 4 feet. It's got to be the same units as the height. So the width would be 4 feet, and the height would be 6 feet. There are other ways to do this. You could see what did this get multiplied by and then multiply this by the same thing. But I've just found that students like this way the best. But if you're hearing that and you like that way better, that's fine. So for instance, 6 divided by 3.375 is 1.777 repeating. So you could just take that times the 2.25 and you would also get the 4 feet. But as I said, most students I've found really like the cross multiplication. So they'll just cross multiply here, get the 3.375W, cross multiply here, get the 13.5, and then you just divide by that number in front of the W. And I'm not going to write a brief memo here to the artist explaining how she can tell which option is correct, but we have, again, gone through 3 different ones. So I'll say method A is top and bottom, numerator and denominator, multiplied or divided by the same thing. Or you can check with cross multiplication. To see if you get the same number. Or you can divide each to see if you get the same number. So remember down here we divided 1.67 by 2.49 and then 23.38 divided by 34.86 to see if we got the same number. So you could divide to see if you get the same number. And this of course is after setting up the proportion. So to set up the proportion, we took the original width over the original height, and we set that equal to whether it was the banner or the billboard or the t-shirt. We took the new width and the new height. And there are other ways to set up this proportion, but I'm going to stick with this way because I think it makes the most sense to people. I could actually flip these two around and put the height on top and the width on the bottom, as long as I flipped both of them. And I could actually also put original width over new width and then original height over new height. There's 4 different ways to set this up. But again, I like to set it up going off of what they have. I think the way that makes most sense is to take the original width and height and then compare that to the new width and height. So continuing with the logo theme that we started in part A, it says that we had this college logo that was 2.25 wide by 3.375 long, and we enlarged it so its new length was 6 feet. You may have set up the proportion like this, which is exactly how we set it up, except instead of putting an X here, we set it up with a W to help us remember that it was width. I think that's a good plan rather than using an X that you can maybe forget what it means. So we used a W here. But other than that, we did set it up like this. So it says, is the proportion below also a correct representation? If so, how would you solve it? Well, we talked about in that lesson and also in prior lesson that if you take both sides of an equation and flip the fraction around, that it'll still be equivalent. So you notice here they've flipped the 3.375 to the top and the 2.25 to the bottom. Over here they've switched the 6 and the, we'll call this a W again. They've switched the 6 and the W around, and so this should still be a correct representation. It should still be okay. And you'll notice that when you do cross multiplication like we did, so 6 times the 2.25 like we did before, you again get 13.5. That's the same two numbers we multiplied before. So 2.25 times 6 or 6 times 2.25, we're going to get the same thing. And then over here, if you cross multiply this way, you're still going to get 3.375 W. And that's why these are okay, because when you cross multiply, you get the same things anyway. So then we divided by 3.375 to find out that the width of the banner, or the billboard, would be 4 feet. Let me write down the other ways just in case you're curious, but again, I would just stick with, one way that you're comfortable with. But you could also write this 3.375 to 6 equals 2.25 to W. W's are hard to write with this tablet, sorry. To W. And again, you'll notice if you cross multiply, you still get the 2.25 times the 6 and the 3.375 times the W. This is height to height and width to width. So height of the original, height of the new one, and then width of the original, width of the new one. And it still gives us the same one. And then we could flip this around, just like we did over here, and just put the top on the bottom and the bottom on the top. Switch the numerators and denominators. Again, if we cross multiplied, we'd get the same thing. So as I said before, there are 4 different ways to set this up, but you don't need to set it up 4 different ways. And so a lot of students will just stick with this however it's given. So in this problem it was width to height, and just do that again on the other one, width to height. Just make sure that they match up, width to height and width to height. Okay, so now it says on these they just want us to solve the equation. So just a little practice solving proportions. So this is already set up. How would you solve that? You would just cross multiply here, cross multiply here. I like to write it underneath, but there's not room, so I'll write it over here. So 0.2x, 0.2 times x, 0.2x, and then 12.7 times 3 is 38.1. And then we're going to divide both sides by the 0.2, since that's the number that we need to get rid of in front of the x. So divide by 0.2, divide by 0.2, and we get that x is 190.5. So 12.7 to 190.5 would be the same as 0.2 to 3. So this one, I'd recommend you pause and try to solve this one on your own and see if you're doing okay on it. So go ahead and pause the video, try this one on your own, and then start it back up and see if you matched up. Then you'll be confident that you know how to do it. So hopefully now you've returned from your pause if you paused, and we're going to cross multiply, and x times 4200 would give us 4200x. And then 8,500 times 5 would give us 42,500. And so to get rid of the number in front of the x, we're going to divide by 4,200. It should go in almost, or a little over 10 times, because if it was 42,000 divided by 4,200, it would go in 10 times. So 42,500 divided by 4,200, we get 10.0 10.1 approximately. And it's up to you where you decide to round that. If it doesn't specify, then you can round to wherever you want. I hardly ever will specify in a test. I'll just let you decide where you think it's appropriate to round to. And then usually in the homework, because the computer's checking it, they'll tell you what to round to. So in this case, it's 10.119. So I'm going to go ahead and round it to 10.12 because it was 11 with a 9 after it. The next problem, it says many small engines for saws and motorcycles and utility tractors require a mixture of oil. They call it or mixture of oil and gas. They usually will just call it mix gas. And the other things that you may see that have that you may use on a more regular basis are weed eaters. Often have that. So if you've used any of those and you've had to go buy a little bottle of oil to mix with your gas to put in your weed eater or your saw or whatever, that's called mix gas. You have to mix that correctly or it will mess things up. Oftentimes what they sell in the store will be just the right amount to mix with a gallon of gas. But say you didn't have that, say you were buying it in bigger quantities and you needed to make sure that you mixed it correctly, or you didn't have a full gallon or you had more than 1 gallon, how would you do that? Well, you could set up a proportion for that. So it says if an engine requires 20 ounces of oil for 5 gallons of gas, and again this is oil to gas, and we just have to make sure that we set up the other proportion the same. So we put the oil on the top, the gas on the bottom. So over here, how much oil would be needed? So we don't know how much oil. I'm going to put L for oil because O would be a bad choice for a variable since it looks like a 0. So I'll put L for oil, and then we have 8 gallons of gas. So oil to gas, oil to gas. We're going to cross multiply, and we get 5L equals 20 times 8 would be 160. And then to get the L alone, to figure out what the amount of oil is, we're going to divide by 5. And L is 32 ounces. And that's just 160 divided by 5. Gets 32 ounces. So if you had 8 gallons of gas that you wanted to turn into mixed gas, you'd have to put in 32 ounces of oil to make that right, to make that work correctly. Then lastly, it says write your own problem similar to question 4 about a situation that has meaning in your life. Your example should not use a unit rate, so we don't want to do 35 miles per hour or 35 miles per 1 gallon or that type of thing. But there's lots of situations where you could use this. One place that I always tell students you can use this on that you might not think of is if you're trying to figure out how much money you made in a certain week or month and how many taxes are going to get taken out. So I'll put one up here about that. So say in one week you worked and you made $450. Okay, and out of that $450 you made in earnings, they took out say $80 in taxes. So in your check you actually got $370 because they took $80 out in taxes. So you multiplied, you made whatever your wage is, and you multiplied it times your hours, and you said, hey, I'm going to get a check with $450 on it. And then you get that back and you realize, oh, they took out $80 of taxes. What would happen the next week? Well, say the next week you only made $320. How much would they take out in taxes? Well, you could set up a proportion. If out of $450 they took out $80 in taxes, then the next week if you made $320, it should be the same proportion. It's usually fairly close. It's not perfect because there's some other things involved besides just a strict percentage, but it's usually pretty close. So if you cross multiplied this, 320 times 80, you get 25,600. And then over here, when you cross multiply, you get 450t. And so 25,600 divided by 450. So divide this by 450. You would have in taxes, let me do that the other way since I wrote that equation the other way. Don't want to confuse anything. So that comes out to be about $56.89. So about $57 in taxes would be taken out. So you could estimate, if you know by your hourly wage you're supposed to be bringing home $320, then you could estimate they're going to take out $55 to $60 worth of taxes, and you could have a better estimate of how much your check is actually going to be. So this is what they mean by write your own problem, something that has meaning in your life. There's lots and lots of situations where these proportions are used. You know, they did the artwork, they did the mixed gas, and it's used in scale drawings. I showed the one here with taxes. There's a lot of different scenarios. They even gave the idea here of miles per gallon. So if you know you went 700 miles and it took you 20 gallons, then you could figure out, well, how far can I go on 8 gallons? And you could use this same idea.